Oh my goodness, we have period 4. Y'all need this math help right now. We're not looking at this test. This is the 80. No, this is period 2 as well. Period 2 and period 4. Algebra 2, we are looking at the difficult test. Look at this. I've finally got a little bit of money in my pocket. Paycheck came in. Hold up, Ma. We finally got a quarter. We got a test on Monday, guys. You asked for it. You voted for it. And we are getting it on Monday. First off, last night I was out at the football game until 10 p.m. And you know I watched that football game. First off, shout out Bejan. You had an excellent interception. That was a sick interception. Top 3 all time. That was sick. I know you know that was a sick interception. And Mekhi had that sick touchdown towards the beginning. That was a sick catch. Good stuff, guys. Good stuff, Michael. You freaking steamrolled through that team. You guys did some nasty work on that team. So good job for all you guys that crushed it at that game. I saw Elijah out there making plays, always making sure that the team is watching. I saw some good defensive plays. Sheldon, bro, you got to stop talking that smack to the other team, okay? You could do it in my class, but don't do it. Well, also don't do it in my class, but don't do it to the other team. That was it was fun to watch though. You're like, oh, my bad, ref, my bad. That was funny. And Joel, shout out. Thank you, Joel, for going out to the games and supporting the football players. And it was nice getting to chat with you a little bit. So go to the football game, guys. Go to the football games. We got a few more coming up. And it sucks that the field got burned down, but it's coming back. It's coming back, and we'll get it. So let's get to the real thing. We got math to do. Hold on. I got to really quickly. This is not a sponsorship, but I need to crack a cold one while I'm doing this with you guys because my Saturday is incomplete without a Good and Gather Black Raspberry Acai sparkling water. Okay, this is water. This is absolutely no substance. The best drink money can buy. Here we go. Oh my goodness, I'm ready to do math now. All right. I hope you guys are able to do these linear functions. This is supposed to be easy work, but I gave you guys problems on this at the beginning of the year. Therefore, we need to be tested on it. Linear equations have the format y equals mx plus b. We should know this is linear because there are no absolute value signs. There's no exponent. There's no exponent to the power 2. The b in this case is 0. The slope is -2. We got to turn it into a fraction, -2/1. We are starting here, going down 2 to the right 1. Down 2 to the right 1. We going fast on this one. Let's go. Up 2 to the left 1. I don't think I congratulated Mildred on doing the cheerleading, but thank you. Thank you to everyone on the cheer team. I haven't gone out and played tennis with you guys. Millie and Melissa, we are gonna rally a little bit shortly. This week, I'm promising you live on video. Heads I win, tails you lose. I win. I'm going to rally a little bit at the tennis courts with you guys after school this week. I promise. And I've said it. It has to happen now. We've got another equation. Linear. Again, it's linear. Not too much about it. The y-intercept's -6. The slope is -3. Turn it into a fraction, -3/1. That means we are going down 3 to the right 1. Alternatively, up 3 to the left 1. Let's see what happens here. This orange is just a disgusting orange color. I'm not using this pen anymore. I'm using these 3 now. We start at the y-intercept. We can try to go down 3/1. It kind of ends there. Let's do it in the opposite direction. Up 3/1. Up 3 left 1, up 3 left 1, up 3 left 1, until the world ends. Okay, remember that. It's always up 3 left 1. And we're going to make a line like that. There we go. Next equation, much much more difficult. Is it actually much more difficult? I don't think so. We have an absolute value sign, so we know that that's the parent function we're going to be using. We got to find the A, we've got to find the H, we've got to find the K. I'm going to write up the original equation up here. X minus 1, whoa, minus 5. Made a mistake on pen, don't use pen. And I'm just going to quickly shout out these pens. Tamit, the worst pen money can buy. I bought like 200 of these for like $10 though, so what am I complaining about? Truly some of the worst quality pens. I have no idea how it has like a 4.3 out of 5 on Amazon. Never recommend these. I could not recommend these less. May you be tammed to math, to the math inferno that is this test on Monday. All right, we have A equals, there's nothing there. It's going to be a 1 because if there's nothing there, we can imagine this is a 1 times this. It's going to be 1 over 1. We got the H, which is, looking at this, going to be the opposite of what we find. It's a -1, so the H is going to be a +1. The K is going to be -5. The K doesn't change. The H goes to the opposite because it's like a minus negative. It's because of that dreaded minus sign right there. So, you know what? The vertex is at 1, -5. So we're going to go 1, -5. That is the vertex there. We know it's going to be a V-shaped because it is an absolute value function. We're going to go up 1 and to the left and right 1. Up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1 to the right. And we're going to do the same to the left. And I'm going through this quickly because, frankly, this should be an easy question for you if you are taking the A test. We are going to get into the more difficult ones shortly. There we go. And that's what it's going to look like. Not going to do this, but I'll tell you, the A value is -2. It's going to look something like that where we go down 2 and over and left 1. You guys can take a look at the answers, which are, by the way, on the back. So I'm not going to spend too much time on that. We are going to go to number 5, sure. What kind of function is it? We've got absolute value signs. We know it's absolute value. We're going to graph it out. H and K. And what are we doing here? H is going to be... Sorry, A is going to be -2 over 1. The H is going to be 0, and the K is going to be a +3. So the vertex is at 0, 3 is the vertex. Vertex is going to be here, and we're going to go down 2 over 1, down 2 over 1, down 2 over 1 in the opposite direction, down 2 over 1 in the opposite direction. And this is the original. This is the original equation here. Or as the Spanish speakers may call it, original. Okay. We are now translating it 3 down and reflecting it. So what happens when we reflect it? The A, it's like a V that's going to go like this, and then it's going to get reflected, so it's going to look like that. So the A is going to go from a -2 to a +2 over 1. That means we're going to go up 2 into the left and right 1. And we're going to go 3 down. So the vertex is going to go, really quickly. Oh, I messed up. Dang it. You see what I did? I saw the 3 down. I don't know why I did 3 down. The vertex is 0, 3. Scratch this, dude. The vertex is up here. I'm messing up. Even teachers make mistakes. Everybody has those days. Whoa. In the words of famous Hannah Montana. That's actually what the original equation is going to look like. I'm so sorry Don't do this in pen. Please don't do this in pen. This is incorrect. That is incorrect. Don't do that. This is what it should look like. 0, 3. Oh, hurts me on the inside. But we're going to take the vertex and we are going to go down 3. So we're going to take the vertex and we're going to go down 3. That's where the new vertex is. So the new vertex is going to be at 0, 0 is the new vertex. And the new slope or the new A value is going to be 2 positive. So we're going to go up 2 over 1, 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 up 2 over 1. And it's going to look like this. This is where the new equation is going to be. Do not think you are finished yet, because we're never finished in this class. We're never finished acquiring that knowledge. So take a look. The last thing we need to do is we need to also write the new equation. The new equation. Where is the y-intercept? Here, I'll write it out for you guys. We have a y equals ax minus h plus k. Well, this is the h and this is the k. So this is going to be like x minus 0, the absolute value of x minus 0 plus 0. And this is going to be 2. So really, this is just 2 absolute value of x. And that's the new equation. You don't have to add those zeros in there. If you really want, write this out as well. If you really want to be precise and say we are subtracting 0 and adding 0, I won't hold it against you. This is truly what every authority in your life wants you to write when you're describing an absolute value function at the origin. We'll also, just a little vocabulary reminder, this is called the origin. Okay. This one is going to be what kind of function? A linear function. So we know it's going to be y equals mx plus b. We can graph it out. Start at the 5. We're going to go down 1 over 1, down 1 over 1, down 1 over 1. We got the m is negative 1 over 1. The b is 5. Take our line, make it straight. It's okay if our lines are curved sometimes, but in this case, we want our line straight. What are we doing? We're translating 4 up. So that means every point's going to go 4 up. Now, if I want to actually write out the math for this, this is what ends up happening. We have a y equals negative x plus 5, but we're going 4 up, so we're going to add 4 to it. So the new equation is going to be y equals negative x plus 9. And it means it's going to intersect at the y-axis right here at 1, at 9. And we can take every point 1, 2, 3, 4, move it up 4. Here, I'm going to do this in red, actually. We got this, 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 this. Look at this. Every point is moving up 4. And there's the line. So that is the new line with this transformation of translating it up 4. Okay. Over here, we've got it translating 10 left and 10 up. What does that mean? It's going to be off. It's going to be, if we graph this out, it's going to be at positive 2 is where the vertex is going to be. We're going to go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. That's the original absolute value function. But now every point is going to be going up 10 left and 10 up. So this point's going to go 10 left. I don't even think we have it there. We can't even go 10 left here. So that's the problem. The problem is I haven't given you enough room. But that doesn't matter because we can use the equation of it. We have a -3. Oh, I don't like that orange. That orange just looks terrible, dude. We got -3 absolute value of x minus 2 plus 2. And that's what the function is. But now we're going to move it 10 left, so we're going to add 10 to this. And we're going 10 up, so we're going to add 10 to this. So it's really going to be y equals -3x plus 8 plus 12. So the origin, this is the new equation, the origin is going to go to the right 8, or to the left 8, and up 12. It's going to go kind of up here. And then it's going to go down 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And it's going to go in that opposite direction. 1, 2, 3, 1. It's going to be like this. And then like something that looks like this. But it's off the grid. It's off the map. It's off totally. But we can check a couple points to see if that works out well. Let's check this point. We go left 10, up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that. That point right there is this point. And if we go down one more, 1, 2, 3, 1. Let's take a look at this point. It's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. Another point right there. So it does work. If we look at the origin, if we look at the vertex, it's also going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. So it does work out. This is going to be the new equation. I'm giving you a translation that goes off of the graph because I want you to be able to do the algebraic manipulation of the equations. Okay. This one. This is what type of function? This is a linear function. This is the original linear function. -3 is where we start, and we're going to go down 4, 1, 2, 3, 4, over 1, up 1, 2, 3, 4, left 1. That's what the original line is going to look like, something like this. It's going to look something like that. Now I want you to go 4 to the right. 1, 2, 3. Is that 4 right there? Yes. And I'm going to go 1, 2, 3, 1. 1, 2, 3, 1. And you'll see it also goes off the graph. This is the new line. I'll do this in red, actually. Let's do this in red. This is the new line going 4 to the right. But where is that y-intercept going to be? Well, here's how we do it mathematically. We have a y equals -4x minus 3. We're going 4 to the right. So that means this is kind of the equation that we're going to have. Y equals -4x minus 4 minus 3. And then we're going to do some distribution. -4x, -4 times -4 is going to give me a positive 16. Oh, I graphed this a little wrong because I'm supposed to go down 4. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. That's actually what the line is supposed to look like. And, 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. That's actually what it's supposed to look like. Something like this. Doesn't look super neat. I'm sorry. I'm making mistakes, guys. It is Saturday, and I'm doing it in pen. That's why you got to do it in pencil. The next video will come at you slightly in pencil. I'm ashamed of myself. Truly. Going back to this. We have this positive 16 and this negative 3. The new equation is going to be negative 4x plus 16 minus 3 is going to give me a positive 13. So that means that this is going to intersect somewhere up here is where it's going to intersect the y-axis. That was a kind of bad explanation. I made a mistake, so that probably confused you a little bit. I'm not going to lie, guys. I just don't want to redo the question and post another video because I've already spent 20 minutes on this. So we're just going to keep on moving on. Pause it if you need to. Think about it a little bit. Comment a question if you have a question about it. Okay. We have some quadratic functions. Let's take a look at 10, because I believe that we did 9 in class for at least one of the periods. So we have a quadratic function because of that exponent, 3x plus 1 to the power 2 plus 2, 3 times the quantity of x plus 1 to the power 2 plus 2. This is the quadratic form. Y equals ax minus h plus k. Very, very similar to the absolute value form. Our h is going to be negative 1. Our k is going to be 2. So that means we're going to go negative 1, positive 2. That's the vertex right there. Now we've got our x and y graph. The first x is negative 1, and the first y is 2. We need to find the point over here where x equals 0 and where x equals 1. So we're going to go 0 and 1, and we're going to see what is the y value. We're going to use the original. Can you see this? I don't know if you could see the whole graph. It's hard for me to see exactly how much space I have to work with. We're going to take the original equation, the original function, x plus 1 to the power 2 plus 2. And we're going to plug in 0 for x. So it's going to be 0 plus 1 to the power 2 plus 2. This is going to give me a 1 to the power 2 plus 2. This is going to give me a 3 times 1 plus 2, which is going to give me a 3 plus 2, which is going to give me a 5. So when x is 0, y is 5. Right here, 0, 5. When x is 1, let's see what happens. We have let's do it over here. I'll do it in green just so we can know it's a different value. X plus 1 to the power 2 plus 2. We're going to replace x with 1. So we're going to get y equals 3 times the quantity of 1 plus 1 to the power 2 plus 2, which is going to give us 3 times 1 plus 1 is 2 to the power 2 plus 2, which is going to give us 3 times 4 plus 2, which is going to give us 12 plus 2, which is going to give us 14. So we're going to go doot, doot. And so this is what our quadratic function looks like on the right side. Now we need to do it on the left side. So it's going to be at negative 2, and we can move this down a little bit. We know that at negative, let's just do this. Negative 2, we're going to have a value of 5. And at negative 3, we're going to have a value of 14. At negative 2, we're going to have a value of 5. Right there, so it's symmetric. At negative 3, we're going to have a value of 14. There we go. So like these ones are symmetric to these ones. You can see that the y values are the same. And you can see that the y values are the same for these two because they're like a mirror. And they're mirroring on the axis of symmetry, which we will get to in the next chapter. I cannot wait for the life of me to get into quadratics because quadratics are possibly the best. The best type of function. So there we go. We've got y equals 14. On this one, we've got y equals 5 on this one. We get these points, graph them. That's how we do it.